We're looking at inheritance in Java. Inheritance is one of the three main concepts of object-oriented programming, along with encapsulation and polymorphism. We're also going to touch on polymorphism briefly because it's so closely connected to inheritance. I'll put some links in the description to some of my other object-oriented videos and also to my favorite Java book, which does an awesome job explaining polymorphism, encapsulation, and inheritance. So I have an empty class right here called game. And let's say we're making a game in here and we want to make all kinds of animals in the game. We want to make like cats, dogs, hamsters, birds, all sorts of different animals. So we want to start out just by going cat1 equals new cat. And then we're going to write a cat class that has all the information that Java needs for making a cat inside of our game. So we're going to make a cat class inside of the same folder as our game class. So I can right click the project or the source folder or the default package, whatever, and just hit new class. Any of these will put the class inside of the same class as the game class. So I'll call it cat, and I'm not going to give it a main method. And this cat class is just going to be a blueprint for making cats inside of our game. So let's just go string name. So every cat is going to have a name. And then we'll go boolean is mean. And then let's give the cat a method. Let's say bite humans. And we'll make this method public void. So now we can make cats inside of our game class. And let's say we also want to be able to make dogs and birds and hamsters in the same way. And let's say that dogs and birds and hamsters are all also going to be able to bite humans. So they'll have the same method. And they're also all going to have names and a boolean is mean that says whether they're mean or not. So we could write out all of this info for each of those animals and just copy out this code like 5 times. And maybe we want a lot more animals than that. Maybe we'll copy it out like 100 times if our game's filled with animals. Or we could just write it out once. So we can go public class, and I'm going to change our cat class to an animal class. And then I'll also change the name of the file to animal so that it matches the name of the class. So now we have an animal class, and we're going to make all of our animals inherit from this animal class, which means that all of them are going to have the attribute name, the attribute is mean, and the method bite humans, even though we won't have to write it out for every single animal. So if we go into our project and inside of the same folder, we make a cat class again without a main method. And public class cat is going to extend animal. So we write extends animal. So now the cat is an animal. So there's a lot of different terminologies that people use here. We can say that the extends keyword pretty much means inherits from. So cat inherits from animal. And this relationship is sometimes referred to as an is a relationship. So cat is a animal. And then we could also say cat is a subclass of animal, or it is the derived class or the child class. And then we could also say that animal is the superclass of cat, aka the base class or the parent class. So there's a lot of different terms for these. All that we really need to know is that a cat is an animal, which means that when we make cats, they can use all of the animal methods and they have all of the animal attributes, which right now is just name and is mean. So right now we could go into game and we could make our cats bite humans. So cat1 dot bite humans. And let's just put some code inside of bite humans. I'll just put system.out.println bites human. So now if we run this inside of our game class, then we're going to get bites human printed out. So our cat is an animal, so it can do all of the things that animals can do. And then if we go into the same folder and we make another new class, then we can just make a dog in the exact same way. And it's also going to be able to do all of the things that animals can do. So if dog extends animal, then now we can go into our game and make dogs, and dogs will also be able to bite humans. So this is inheritance in a nutshell. just making one class that other classes inherit from, and those classes inherit the methods and the instance variables of the base class or the superclass, whatever you want to call it. There's a lot more to it, but really this is the basic idea to understand. One thing we might want to do in our program is make animal an abstract class, just so that people can't actually make animals, because animal is kind of ambiguous. If we're making animals in our program, then there's the obvious question of, well, what kind of animal is it? What does it do? What does it look like? So we don't want people to be able to just straight up go animal 1 equals new animal and instantiate an animal, because then our program might not know what to do with it because it doesn't know, is it a dog? Is it a cat? What is this? So then we go and we make our animal class abstract just by writing abstract in front of class. So now animal is an abstract class and you can't just make an instance of it. So now Eclipse has underlined animal in red and says, no, you can't do this. We can still make animal variables. So this variable isn't underlined. This is still legit. And we can do something called polymorphism, where we just go animal 1 equals new cat. Before we get too into what that would actually do, there's some other inheritance basics that I want to look at. Let's go to our animal class and let's make another method called make noise. So we're going to say all animals can make noise. So public void make noise doesn't have any parameters, and inside of it I'm just going to print out makes noise like an animal. So now all animals can make noise like an animal. Let's make our cat make some noise. So we'll go cat1 dot make noise, and then I'll run this. So the cat's gonna bite the human and then it's gonna make some noise like an animal. And now let's say for our cat, we want it to be able to make a noise that's more specific to a cat. We still want all animals to be able to make noise if we don't write some default noise that they make, but we want our cat to specifically be able to make a cat noise. So if we go inside cat, then we're going to do something called method overriding. Method overriding is writing two different versions of the same method. One version goes into subclass and the other version goes into superclass. So the superclass animal has the version of make noise, and then our subclass cat is also going to have make noise. So I'm just going to copy and paste it right into cat, and then inside of cat, instead of making noise like an animal, it's going to meow. And the version of make noise that automatically gets executed by Java is the version that's in the subclass. So the version in the subclass overrides the version in the superclass, and this is what's going to run at runtime. So now our cat will meow instead of just making noise like an animal. Our dog, however, we haven't written a make noise method for, so if we made a dog right now and we just went dog1 equals new dog and we just get it to make noise, then our dog is just going to make noise like an animal. So here we'll get bites human and then makes noise like an animal and then meow. Because our dog makes the noise like the animal, but our cat meows because we overrode the make noise method inside of our cat class. And then maybe for the purpose of our program, we decide, hey, I don't want animals just to be able to make noise like an animal. That's too generic, that's ambiguous. I want to know if they bark or if they meow, if they ribbit or whatever. So then we can just go into our animal class and we can make this method abstract. So if we go public abstract void make noise, and abstract methods don't have bodies, so we're going to get rid of this body. And having an abstract method like this just means that every single class that inherits from animal has to write its own version of make noise. Otherwise, it's not allowed to be an animal. And it's worth noting that abstract methods can only be placed inside of abstract classes. So that's fine for us right now. We wanted our animal class to be abstract, but this won't work to put an abstract method inside of a class that isn't abstract. So now if we go back to our game class and we try getting our dog to make noise, let's see what happens. It says errors exist in project, and that's because our dog class has an error now because it doesn't have a make noise method and it's an animal, and we've declared inside of our animal abstract class that every single animal must make noise because we have an abstract method called make noise. So I'm just going to copy and paste cat's make noise method, and I'll put it into dog, and we're just going to say woof. So now our dog woofs and our cat meows. So we get bites human from the original cat that we had, and then the dog woofs and the cat meows. And one of the coolest things about inheritance is polymorphism. There's a few different ways that people define polymorphism, so depending who you're talking to, you might get a different answer. But right now, you could say that there's polymorphism happening in two places inside of our game. We have polymorphism happening when we make a cat and then store it inside of an animal variable. And we had polymorphism happening before we made our makeNoise class abstract, back when we had a makeNoise implementation inside of animal, and we had a makeNoise implementation inside of cat. And at runtime, Java just decides, hey, I'm going to run the version in cat because cat is the subclass, and the version that's in the subclass is always the version that's going to run. So that's another version of what people call runtime polymorphism. Again, depending who you're talking to, I've heard a lot of different people give different descriptions of what exactly fits the technical description of polymorphism. But pretty much it's Java's ability to say at runtime, hey, you can make a cat and you can put it inside of an animal variable. That's all good because I know cats are animals. And if you make your cat meow, then that's all good too. If you make it use the makeNoise method, I'll know that it wants to make noise like a cat and not just use the generic animal make noise. That's all good. So it's just kind of giving you flexibility in your code. Let's make cat2 and dog2, and let's store them inside of animal variables. Let's go animal cat2 equals new cat, and animal dog2 equals new dog. And now if we write a method inside of our game that just makes all of the animals make noise, we'll call it public void all animals make noise. And then we just pass into this animals make noise method an array list with our animals inside of it. So it'll take in an array list of animals, and we'll just call it animal list. Animal should be singular here, sorry. So it takes in an array list of animals, and I'll import array list. And then we'll fill up our array list with our cats and our dogs. Let's go array list animal equals new array list animal. And we said we were going to call it animal list. So now we can fill up our array list with our dogs and our cats. Let's go animal list dot add cat2 and dog2. So if we run this right now, then we're passing an array list of animals to our method all animals make noise. And then inside of here, we're just going to write a for each loop that just takes the animals and makes all of them make noise. So if we go for animal A inside of our animal list, and then we're going to say a dot make noise. And this is polymorphism in action. So Java decides, hey, okay, A is an animal and all animals can make noise. And at runtime, I'll decide which version of make noise should run based on what kind of animal A is. And what's especially cool about this is that this method will even work for any animals that people write in the future that don't even exist at the time that this method was wrote. As long as they're animals, then we know they're going to have a make noise method, because in our animal class, we made make noise an abstract method, forcing any animal to have a version of make noise in order to be a valid animal. So this method is going to work on any animals that might get made in the program. Even animals that might look very different from dogs and cats and have a whole bunch of other methods, we know they're going to have a make noise method. Now let's go back to our cat class. And let's say we decide at some point in the program that not only do we want cats to be animals, we also want them to be pets. So we want them to be animals and pets. Java is single inheritance, which means we can't make cat extends animal and pets. Other programming languages like C++, you can do multiple inheritance, but you can't do it in Java. But there is a way to kind of simulate it. We go cat extends animal, implements pet. And this is called implementing an interface. So we're going to make an interface called pet, And that way our cats will be able to be animals and also pets at the same time. So if we go back to our folder that has all of our classes in it and we make a new class, and we'll just call it pet, and then we change class to interface, then we have public interface pet, and then let's write some pet methods in here. Let's go void beg for food. And interfaces are really cool and can be a little bit confusing at first. They're used all the time in Java, so it's worth wrapping your head around. Inside of an interface, any method by default is public and abstract. So without writing public abstract here, this method is already public and abstract. We don't have to write it in there. And the purpose of this is to make it so that anything that is a pet must, by necessity, have an implementation of a beg for food. So now we have an error in our cat and it's going to say, hey, there's no beg for food method in here. So therefore cat is not allowed to be a pet. So if we go public void beg for food and we write an implementation of the beg for food method, beg for food, then now our cat is allowed to be a pet because it's implemented all the methods from the interface pet. So interfaces generally tend to be just collections of abstract methods and public static final variables. Any variable that you make inside of an interface by default is public, static, and final. The same way that the methods by default are public and abstract without writing anything, then the variables by default are public, static, and final. And the most common use of variables in interfaces is when you have interfaces that are just like filled with conversion numbers and stuff like that. So like if you have the conversion number for like pounds to kilograms and meters to feet and all that, then you could just like make cats implement conversions. And then this class would have access to all of those numbers. That's it for this video. Thanks for watching. I'll put some awesome resources in the description just to some of my other object-oriented programming videos and to some awesome books for anyone learning Java.